Hey students, welcome back. In this video we're going to be covering ionic compounds. So we just talked about, maybe you watched ions forming and why elements want to gain or lose electrons. We'll talk about the compounds that form from ionic interactions between elements. Those are our ionic compounds. So ionic compounds form from a metal and a nonmetal. Remember, our metals are represented in green here. Most of the periodic table is made up of metals. So generally we say they're on the left side, right? And that's pretty much the whole left-hand side of the periodic table. Nonmetals in pink, this is our right side. And then our noble gases, remember from our last video, these guys don't react. So an ionic compound always forms from a metal plus a nonmetal. Okay. If you have two nonmetals, that's going to be a covalent compound. That's something different. So ionic compounds always create ions. So you're always going to have an element that's a cation, something with a positive charge, and an anion, something with a negative charge. So one element is going to be donating an atom. That's going to be the one that turns into the cation. And the other one is going to be receiving an electron. That's going to be our anion. So big idea, ionic compounds form when valence electrons are transferred between atoms. If we take a look at this simple ionic compounds table, we can look at a few things. Let's just start on the left side. Okay, so we have sodium chloride to start. If we look on the first row, sodium wants to form a +1 charge because it has one valence electron. It wants to lose that electron. Chlorine has the opposite problem. It's in the 7th column, or group 7A. So it wants to gain an electron. So these guys are going to form a compound with a 1-to-1 ratio because they're going to cancel out perfectly. Right? We only need one sodium ion to cancel out one chlorine ion. If we look at calcium and oxygen, calcium's in the second group. So it has two valence electrons, and it will form a 2+ cation. Oxygen, group 6A, it's going to form a -2 charge. So these guys are also a 1-to-1 ratio. So as we can see in this compound, we just have one of each, right? And then gallium and arsenium, these guys are +3 and -3 respectively, based off of how many valence electrons they have. So also 1-to-1 ratio. Okay, so we're just looking at 1-to-1 ratios currently with our ionic compounds. We'll take a look here at when they are uneven, how we cancel them out. So, and this kind of leads us to our rule of zero charge. The net charge of an ionic compound is always 0, right? Ionic compounds always have to add up to 0. And that's what the rule is talking about. Because your positive charges always need to cancel out with your negative charges. It's conserving charges. The electrons can't just magically disappear. They have to go somewhere. So every time a metal atom and a nonmetal atom bond, they form a compound with an overall 0 charge. Okay. So if we look at those three compounds we just looked at in the table, right? Sodium chloride +1 -1, calcium oxide +2 -2, gallium arsenide +3 -3. And if we added these together, right, that would equal 0. Okay. When we get to different charges, we have to make different ratios so that they cancel out. And if we look at these charges we've created, or the valence electrons that each element has, each compound, we look at the valence electrons of both elements, they all add up to 8 valence electrons, right? 3 valence electrons plus 5 valence electrons, that's going to be 8, 2 and 6, and 1 and 7. Kind of like when you roll a dice, the opposite side of a dice, always the top and bottom number or opposite sides always add up to 7, right? Our elements, when we add them up, always add up to 8. So then we get to compounds that are more complex, and that is because they don't always have to be in the complementary group or the complementary valent electron number, right? If we look at the first one, magnesium chloride, we have 2 chlorine atoms here because magnesium wants to form a +2 charge because it's in the second group, and then chlorine wants to form a -1 charge because it's in the 7th column. So if we tried to add those up just 1 to 1, that would give you an overall charge of +1. That's bad. Okay? Very sad. There's a sad person right there. So in order to combat that, we need to add another chlorine ion so that it equals 0. Right, so now this whole thing here equals 0. Happy. So that's where this 2 comes from. You'll need to figure out, given the name of an ionic compound, you'll need to come up with the correct chemical formula with the correct subscripts. And the way you do that is to make sure that they add up to 0. If we look at the next one, sodium and oxygen, sodium forms a +1 charge, oxygen forms a 2- charge, so we know we'll need 2 sodium ions for every 1 oxygen ion. And then we can see that here, right, Na2O, or sodium oxide. And then the last one, aluminum oxide. So this one could be a little tricky if you're doing this for the first time. Aluminum forms a +3 charge. We'll ignore this for a second. Oxygen forms a -2 charge. So we need these guys to add up to 0. Right? This is like a math problem now. We need to figure out how many of each we can have. So this is where we kind of find the lowest common denominator. Right? So what number is the lowest number that 3 and 2 share? 6. So we need to make sure each number adds up or multiplies to 6. So for -2, that'll be 3, in this case 3 oxygen. All right, 3 minus 2 is 6. And then for aluminum, we need a 2 there. So we do 2 times 3. So now we have a +6 charge plus a -6 charge. That'll equal 0. Right? Because now we have this 2 represents our 2 aluminum. This 3 represents our 3 oxygen. So always remember our rule of 0 charge. Ionic compounds need to add up to 0. All right, so another example. The chemical formula for sodium sulfite is Na2S. What is the charge on each sodium ion? Na on each sulfur ion. So this is breaking it down step by step. We can do this one quickly. Sodium is in the first column, so we know sodium is going to have a +1 charge. Each sodium ion is going to have a +1 charge. Sulfur is going to have a -2 charge because it's in group 16 or group 6A, so it wants to gain 2 electrons, so it'll have a -2 charge. So we need to show that the charges on the ions add up to 0. So in this case, we have 2 sodium ions, so we just do +1 plus +1 plus -2, right? Because we only have 1 sulfur ion, and that's going to add up to 0. And then for the second one, is sodium chloride a possible ionic compound? Why or why not? So this is saying that there's 2 sodiums here, so we would have 2 +1 charges, right? Because sodium's +1. Chlorine's always going to form a -1 charge. If we add those up, we get +1. That's very sad. That's a no-go. So this would not work. This is not a possible ionic compound because the charges do not add up to 0. So that's our rule for determining our chemical formula given two elements. The next thing we're going to do is naming ionic compounds. And this is, if you remember these 3 steps, which are very straightforward, you'll get it right every single time. So they are very straightforward. The first rule is just to put the name of the metal atom first. Generally, that's going to be the element on the left, right? Second rule is the name of the nonmetal is second. So far, so good. And the only thing we really need to change when we're naming an ionic compound, besides putting the 2 elements' names together, is the name of the nonmetal is altered by replacing the last part with the letters IDE. Okay. So for this one, if we look at this table, we have sodium and chlorine. So instead of sodium chlorine, we just replace the INE with IDE. So it's now sodium chloride. For the next one, we have magnesium and fluorine. That's just magnesium fluoride. Notice how our subscripts don't influence the names at all. It doesn't matter how many there are. We can know how many there are based off of the ions that they form, again, based off of the column that they're in. So we don't need to detail that information because we should already know. And the expectation is if you see an ionic compound, you should know the charges of the elements. The next one, again, name of the metal, lithium. Name of the nonmetal, sulfur. Replace the ending to IDE. So this is just lithium sulfide. And then the same for these 2, right? Aluminum oxide and then gallium phosphide. So as long as you change that ending and you say their names, you're good to go. And this brings us to our last example problem. So write the chemical formula and name for the compound created from each pair of elements. So to write the chemical formula, this is the heavy lifting because we need to find the charges for each element. So if we look at potassium, or K, and bromine, let's go to the periodic table. Potassium's in the first column. It's number 19. So it's going to have any column in there is going to form a +1 charge. Bromine is in the second to last column, number 35. And anything in that column or group is going to form a -1 charge. So these guys form a 1-to-1 ratio. They'll cancel out right away. So our formula is just keeping it 1-to-1. So this is our formula, and the name for it is going to be potassium bromide. Right, all I did was change that IDE. All right, next one, oxygen. We've talked about oxygen before. It always forms a -2 charge. Potassium, still in the first column, never going to change. That's a +1 charge. So because these guys don't equal 0, right, -2 + 1, that's going to equal -1. We need to add one more potassium, right, to equal out or to cancel out. So in my formula, I'm going to write K2 bromine, right, because these 2 potassiums are going to cancel out. Oh, wait, yeah, these, you know what I did wrong? I wrote the bromine instead of oxygen. Sorry about that. So it's potassium to oxygen. Those 2 potassiums are going to cancel out with the oxygen. So our name is just potassium oxide. All right, next one, sodium has a +1 charge. Then we have oxygen again. Okay, oops. And oxygen is -2. Same thing as letter B, just a different element. So this is going to be Na2O. Right, we need 2 sodium ions to cancel out with our 1 oxygen. And the name is just going to be sodium oxide. Second last one, oxygen -2 again. Man, lots of oxygen. And then calcium is +2. That's in the second group, number 20. So it forms a +2 charge. These guys form a 1-to-1 ratio, right? They cancel out immediately. So that's just going to be CaO, and then that's calcium oxide. And then our last one, E, we have sodium +1. Chlorine is -1. These cancel out again. So we're left with NaCl, sodium chloride. This is also known, common name, as table salt. All right, so that's it for naming ionic compounds. Feel free to watch this video again to get extra practice, or if you need help on the homework or study for the test. Have a good day.